Okay guys, welcome back. So next, I'm going to talk about how we compare these variances between groups versus variances within groups. And we want to talk about how large is large enough to declare that the variances between groups are so large and there is a true difference existing between groups. So to answer this question, we're gonna fill out this form. And eventually we're gonna obtain or calculate this F value. So the logic is pretty similar with the t-test. So we're gonna have this obtained F value for our, this example. And then we're gonna have an F table where we want to compare our obtained F value with the critical F value found in this F table. And similarly with the t-test, if our obtained F value is larger than the critical F value found in the table, we say that the variances of between group is sufficiently larger than the variances of within group. So which means there is a true difference between groups. We're gonna reject the null hypothesis, claiming that, these 5 populations, they have different mean for their stress level. So in other words, the 5 courses do have some influence or do influence people's stress level. So so this is kind of the behind logic of this table, very similar with the t-test t-table. So next, I'm going to talk about how we calculate this F value. We're going to fill out this form. So far we have filled out this SS column, right? If you still remember it, SS stands for sum of squares. So this cell is the sum of squares between groups. And this cell is the sum of squares within group. And this is the sum of square total. Okay? So if you forget, how to calculate these 3 cells, go back to previous slides. Actually, you guys specific equations to calculate these 3 cells. So next, I'm going to talk about how to calculate this degree of freedom and also this MS. So let's talk about degree of freedom first. So for the degree of freedom for between groups, it is the group member minus 1. Okay, so between groups, remember that is, we want to look at how each group mean is different from their grand mean. Okay, so the degree of freedom is the group number minus 1. And for within, remember these variances capture the distance of each individual from their group mean. So the degree of freedom is the total observation number minus the group member. So in our case, we have 50 participants in total, and we have 5 groups here. So the degree of freedom is 50 minus 5, which gave us 45. And the total, that is kind of a measurement of the distance of each individual, how far each individual score is away from their grand mean. Okay, so this will involve every single participant. So the degree of freedom here is the total number of participants. In our case, is 50 minus 1. Okay, so here we have 5 minus 1 for between, which is 4, and for this within is 45. Okay, 50 minus 5. And last one is 50 minus 1, give us 49. So we have filled out this column, we do this column, and next we want to calculate this column. So here I'm going to talk about what does MS mean. MS stands for mean of squares. Okay, mean of squares. I guess you may figure out that it is something related with average with mean. Exactly. So we're gonna take the average value for this sum of squares. So what we're gonna do for this between, we're gonna take the average of the sum of squares between. So what we're going to do is SS between divided by the degree of freedom between. Okay, so to fill out this cell, we're gonna divide this cell by this degree of freedom. So 351.52 divided by 4. This will give us the value for this MS between. And do the same thing for raising. We're going to take the average of sum of squares for raising. So 435.30 divided by 45. And this will be the answer for this MS raising. Okay, we don't need to calculate that one, so don't worry about it. And here we have these two cells filled. Okay, and last step is how to calculate this F value. Eventually, we got here. Remember, F value stands for, to what extent this value is larger than this value. So what we are going to do is take the ratio between this cell, the between MS, and the within MS, and then we're gonna obtain an F value for our question. So we're gonna divide this 87.88 by 9.67. That is our F value. Okay, so our obtained F value is 9.08. Sorry for this stuff, but I think you can tell it. Okay, so this is our precious obtained F value, which we obtained through so many steps. So the next step is we want to decide whether this F value is large enough to claim that the group differences are so big that a true difference exists. So how to decide that? Of course, we have an F table to compare against. But before I talk about how to read the F table, I want to make the connection between the calculation with the logic part of this F test, between, this blue and yellow boxes. I'm going to ask you guys to pay attention to these two numbers, these two values, the MS between and MS within. You will find this MS within magically agrees with the estimate we obtained in this blue box when we make no assumption about null hypothesis. And this MS between would agree with this estimate we obtained in this yellow box when we assume that all these 5 populations have the same mean. So the estimate about the population's variance is actually obtained from each individual's variances from their group means. Okay? Nothing related with the group differences. And the estimate we did in this yellow box actually is obtained based on the group differences. So if there is a huge disagreement between these two estimates, we're gonna say, okay, this null hypothesis is wrong, and these 5 populations don't have the same mean. Okay, so that's kind of the connection I want to make with the logic part. And then next, I'm going to talk about how to read this F table. I have uploaded a copy of this F table in your Canvas. Feel free to download it and use it. Okay, so first, let's talk about the layout of this table. This first row here, it is the degree of freedom between, that is the group member minus 1. And this most left column, it is the degree of freedom within. How to calculate that? It is our observation number, the total number of participants, minus the group member. So in our case, the between we have is 5 minus 1 give us 4. So we are going to look at this column here. And for the degree of freedom within, we have 50 minus 5 groups, which gave us 45. But we don't have 45 here. We're going to look at 40, and 50, and then take the average between these two F values. But let's say if your degree of freedom, let's say, is 58, you can simply kind of round it up to 60 and look at this value here. Okay. So in our case, we have these two kind of nearby F values, 2.61 and 2.56. We are going to take the average of these two F values. So our critical F value is with a degree of freedom between its 4, degree of freedom within 45 at a significance level of 0.05 is 2.58. That is the average between these two nearby values. And our obtained F value, as we worked in the form, is 9.09. Apparently, our obtained F value is larger than its critical T value. So we are going to reject a null hypothesis because the probability of getting such a F value as large as this one, 9.09, is very small. So we are going to go back and reject the null hypothesis, claiming that these 5 populations, they have different means. In other words, these 5 different courses do lead to different levels of stress. Okay, so that is the F test, or we call it Anova. I think this is the most difficult part, probably the most difficult part in our course. I hope this lecture and along with the PowerPoint is clear and kind of easy to follow. But if you have any questions, let me know through email or visit my office hours. I'll be happy to explain them to you. So before, and I also have a kind of one practice for you guys, but before I talk about the one practice, I want to make one correction for one of my previous slides. So it is this equation when we calculate this S between. So we have said that we want to give different weight for different groups because they may have different sample size. So in the previous slide, I put an outside of this sigma symbol, but that's totally wrong, and we want to put this n after this sigma. So which means that we're gonna take the square value first for each group, and then multiply by its sample size, give different weight, and then add them up, right? So again, here I want to make a correction here. I want to put n after this sigma. Okay, here is our practice 2. So practice 1, I ask you guys to, exercise the logic of this Anova test. And practice 2 is to, go through the calculations of Anova. So here again, pick any 3 courses of your interest and answer the question, is there true difference between these 3 courses you picked in terms of causing people stress? So this is kind of the data we have here, 5 groups with 10 people in each group. I've calculated the mean, standard deviation, and the variance for each group here. Also calculated the mean here, the grand mean here, and sum of squares here. So the sum of square actually is the variance multiplied by the degree of freedom for each group. Okay. Please note that you don't need to really calculate this SS total because you got to, do 50 squared values. You just simply kind of add SS between with SS within, that is your SS total. And also note that for SS between, we got to give different group different weight. So we want to take the square value for each group's mean and then multiply by its sample size, which is 10 here, and then add them up, that is SS between. So here is your second practice. Have fun with it, and I look forward to reading your answers.